but more specifically, we created a document summary, which you see here, which contains a number of things. There's, first of all, a tag cloud of those terms that we enrich so you can see what the paper is all about. But here, what we've done is just list those terms from the infectious disease ontology relevant to the content of the paper. And up at the top here, we see a study summary that tries to distill into a few statements what the paper is all about. And this was created, obviously, for this particular paper, but it led to the idea of creating a minimal information standard for infectious disease investigations. And so that's what we're working on at the moment. Here's a draft of it that some of you have received. And we're having a meeting in September where interested parties from the ontology community, from epidemiologists, from WHO, and so on, will come together in Oxford to hammer out a community agreed standard with some controlled vocabulary or ontology terms backing it, that then I hope can be used to create structured digital abstracts in papers, as well as for controlling the metadata that will be used to describe data sets and research results coming from this area. So that is one of the aspects of ontologies interacting with papers that I would like to see develop. And if we go back here, the other one has to do with the citations. We make citations from our papers to other papers, but these are just bold assertions at the end of the paper. If we look at this typical paper here, then down at the end there's a bunch of references. They don't do very much except tell you that that paper was cited. I think we can do better than that. If we go to the enhanced paper, what we see is that we have citation typing. Now, here is the bunch of references, but underlying this is Cito, the citation typing ontology that we've developed, that allows you to describe these papers in greater detail. So, for example, this paper, previous paper, number 6, from the same research group, is used to obtain background information, obtain data. The citing paper confirms it, extends it, it shares authors with it, and so on. And it seems to me that by putting this additional information into your published paper, you will enrich it and enrich the links to the other papers. You can use those statements, if they're encoded in RDF, as we did, to build citation graphs too. Here's a citation network from Co et al., Rees et al., and a number of papers it cites displayed in Welkin as a simple graph arranged along a time axis. And if you want to get fancier, you can start to indicate that network in terms of the number of citations that cited paper has globally received, shown here as the cube root of that number, a little sphere representing how big that cited paper is in the world's eyes, but also the little bumps on the citing paper, the number of times the citing paper cites the cited paper. So these are just some examples, and I'll stop there, but ways that, in practical ways, ontologies can interact with publications.
Okay, thanks, David. So, let's next like to introduce Peter Jackson, who's Chief Scientist at Thomson Reuters. Now, he describes this to me earlier as a global information company. I would probably describe it as something very big. It's an enormous organisation with working on many different things. So Peter runs a research and development team of 45 people to give you a sense of the scale of some of the work. He's been in the internet publishing business since 1995. And was previously professor at Edinburgh University and has published 3 books on artificial intelligence.
Thanks for the introduction. Yeah, I think that I had a hard time organizing my thoughts for this panel, and I think that part of it is that I think publishers are confused by semantic technology, and I think that in general we're trying to kind of work our way through it. I think all the notes I made really for this panel and presentation were all really notes about sort of dichotomies that publishers face, and I think some of them are not just faced by publishers, but in fact by all of us. So, we started with, is it the author or the publisher's responsibility to tag things, for example? To start at something really very basic. I think this is a really difficult question, and we have experience inside of Thomson Reuters of journalists and editors tagging stories, and our experience is that it's very uneven. Even though these people are professionals, they do it all day, every day. One of the things that we've found to be illuminating is that if you then try and use those tags, to train a machine learner, for example, you find that the unevenness and inconsistency in tagging makes that extremely difficult. So some people are going to put 30 tags on a news story. Someone else might put 3 tags on a news story. People are incented in different ways depending upon what kind of story they're writing, as to how widely they want it to be read, and how many topics they think it touches upon. So even if you sort of, in a sense, could solve the problem of author tagging by incenting people, it doesn't necessarily mean they're going to do a good job, and it doesn't necessarily mean you're going to be satisfied with or at all pleased with the results, or that it's going to help you sort of bootstrap yourself into some other kind of world, let's say one with more automation. At the same time, there are certainly people inside of Thomson Reuters who sort of say, well, hybrid systems, that's the answer we have to have. People tagging things, we have to have machines tagging things. And that's very easy to say, but it's not always easy to figure out what's the right allocation of function between person and machine in that kind of a situation. And I think one of the things that people are not very good at generating, they're very good at critiquing and culling things, but they're not so good at generating. Machines, which are mindless, as Alan says, they're often very good at enumerating and generating things. And not all of those things may be wonderful or great or even accurate, but they're very good at that sort of voluminous generation of ideas, tags, and also, obviously, the consistency with which they apply things even when they're wrong. Simply saying, well, let's have hybrid systems, doesn't necessarily give me a very warm or fuzzy feeling. What usually does give me a warm, fuzzy feeling is having a lot of data to play with, and having large amounts of content that I can set programs loose upon. And some of you may have read an article that was written earlier this year by some people from Google. I can't remember all the authors. One was a friend of mine, Fernando Pereira. I think Peter Norvig was an author too, where they basically argued in a rather provocative way that having large amounts of data and smart statistical methods will sort of always beat semantic, high-touch methods. And I don't necessarily believe that, but I think that the puzzle for a corporation like Thomson Reuters, which has huge amounts of content, very heterogeneous, everything from data in databases to in very structured to totally unstructured text and things in between. The challenge for us, I think, really is to everything we do has to scale to an enormous degree, and we're not Google, so we're not just processing web pages, and everything we do doesn't have to be web pages. So I think the challenge for us is to me, it really is that business of digging into the person-machine system and trying to figure out, what is the most productive way. And the thing I'm going to end with, which I think is so much a part of that, is a comment made by Chris Shute this afternoon, where he said, you're building ontologies, but what you want to build doesn't it depend on your use case, doesn't depend on what you're going to use this information for and this metadata for. And I just think that's so true from a publisher's standpoint. And I think we are all the time, to bring up another of these dichotomies, I've got about 10 of them here, I've only touched on 3 of them. The one I'm going to end with is this fact that on the one hand, I think ontology builders, you tend to think that there are these universal truths and things you want to represent and then draw inferences about. But in reality, when people, when you're building a system that's going to be used by, people at a trading desk or by attorneys or by people who are doing pharmaceutical research, those very different use cases and those very different ways of thinking about problem solving, I think really tend to skew any efforts at underlying knowledge representation. And I think to the extent that they don't, probably the product or the service is not going to be successful. To the extent that they do, you're not going to be left with an ontology or representation at the end of the day that has a lot of generality or is even worth sharing within your own company. So those are some of the dilemmas, I think, that we struggle with in publishing. I hope that at least the dilemmas are interesting.
Okay, thanks. So Larry, So Larry is director of the Centre for Computational Pharmacology at University of Colorado for Chase School of Medicine. He works on the development and application of computational techniques to analyze high-throughput data and biomedical text. So Larry.
So I'm going to take Barry wanted me to take radical positions, which is part of my nature, so I'm going to take a few.
Excellent.
I'm going to start off with a couple of claims. So my first claim is that academic publishers, no offense, they employ some very nice people, but no longer provide much value to academics. Authors are unpaid, reviewers are unpaid, editors are mostly unpaid, what they're paid is relatively modest, and yet the academic libraries, which are supported by the indirect costs that our grants generate, spend millions and millions of dollars providing us with access to our own work products. That used to make sense when getting access to those work products required cutting down forests and shipping them around in little boxes so that we could read them, but that's no longer true. And it may be the case that through various means, some upstanding, some more nefarious publishers have managed to continue to capture these millions of dollars to give us access to our own work, but it's not sustainable and it's not going to work, and you guys are going to lose ultimately if that's your business model. And it doesn't apply nearly so much to, say, Thomson Reuters, which is selling aggregated information to people who are not producing it themselves, but it certainly applies to academic publishers. And so that's one claim I'm going to start off with. The second claim I'm going to start off with is that knowledge representation is really hard, and authors are lousy at it. Okay, getting people to try and richly represent the knowledge that they are producing in a way that a machine could properly take advantage of requires a skill set that authors don't have. It's not because they're not properly incented. It's not because they don't want to do it. It's because they can't do it. It's hard. It requires expertise, the kind of expertise that biocurators have. That's one of the lessons, I think, that we have learned through the last decade of doing this stuff, is when you have experts at knowledge representation representing knowledge, that's one of the critical components of getting it right. The other critical component, I would suggest, of getting it right is actually having a good set of ontologies and tools to build the knowledge with. Okay? If you look at inter-annotator agreement, a very coarse measure of quality in representation, MESH gets about 40% inter-annotator agreement among expert taggers, expert indexers at the National Library of Medicine. If you look at what Go annotators get, they're upwards of 80% inter-annotator agreement. And so that suggests that having a high-quality knowledge representation system makes it easier for getting good knowledge representations out. You need experts, you need high-quality systems. The third thing I'd like to start off with, and then I will end with a suggestion, is that this is very expensive. Okay? Developing good ontologies and paying curators costs a lot of money. Right now, that money is sort of squeezed out of various different pots. Okay? I have a comment from Peter Good that they've spent at least 50 million NIH dollars, and it's probably a lot more than that. That's just on grants that have the word ontology in them. It doesn't count the model organism databases that do most of the work. It doesn't count anything outside of the United States. So we think it's reasonable to imagine we spent $100 million on getting as far as we are now.